Greetings, Earthlings! Before we start exploring, don't forget to like, comment, and subscribe, wherever you're listening. It helps more people find the show and supports our mission of making science accessible to everyone. You're here with DJ Stellar Cloud. Thank you for tuning in. Welcome back to the Exploring Your Universe radio show. Exploring Your Universe is UCLA and LA County's largest science fair. Fun fact, we're also completely cost-free, so roll up whenever. Actually, roll up on November 2nd, 2025 from 12 to 5 p.m., not a minute earlier. You're listening to DJ Stellar Cloud, and today I'm here with DJ Seis. DJ Seis, aka Saeed Mohanna, is a PhD candidate in geophysics and space physics studying earthquakes and tsunamis. But more importantly, he is the booth leader for Make Your Own Earthquake. Welcome to the show, DJ Seis.
Thank you. Thanks for having me.
So, what is Make Your Own Earthquake?
So, Make Your Own Earthquake is a booth that came to fruition with my advisors, through my advisors' ideas. Basically, he wanted to share with the public in LA how you can prepare for an earthquake and why earthquakes even happen, especially in an area seismically active as Southern California. And so it consists of a demonstration of the kind of fault that we live near. And we also show how shaking affects buildings of different heights. And we also like to even demonstrate like secondary effects of earthquakes like liquefaction. And so we do that with like a little tank of soil, and we like to show the kids if you have a lot of soil with water, this is what happens when an earthquake occurs. Yeah.
So something that's really funny is that even though I have lived in Los Angeles my entire life, I forgot that earthquake preparedness was a thing. I'm kind of an earth science nerd, so I was just really excited about the idea of having a mini earthquake on the table. But you do bring up a good point about earthquake preparedness. Yeah. What are some tips that you share with the kids at EYU?
Yeah, so I try to basically echo what they might have already heard at school, but if not, I like to tell them if you're indoors, you get under something sturdy like a table. If you're outside, it's better to remain outside away from buildings. And something we always hear in the earthquake community is that, earthquakes don't kill people, buildings do. So you'll want to stay away from the buildings if possible.
That's a really good point. Yeah. You can get shaken really, really hard and survive.
Yeah.
Okay, but they do get to make their own earthquake with the soil and the water, and they get to test out liquefaction. Yeah. Walk us through exactly what happens when someone comes up to your booth.
Yeah, so usually I will, start with hey, want to learn about how the ground shakes? I like to reel them in with something like a small quip like that. And usually the parents are very excited to learn as well. It's not just the kids. That's a great thing. So what I'll do is I'll say, hey, you want to make your own earthquake? And I will turn them over first to the demonstration of the fault, the San Andreas fault. And what it basically is you have two foam boards that are able to be cranked by someone doing a demo.
Oh my gosh, yeah. I know what this is.
Exactly.
I've seen it. Okay, because I'm always cleaning out the demonstration closet.
Yeah.
Okay. So this makes so much sense.
Exactly.
I don't get to walk around EYU, so now I finally get to know whose foam boards those are.
Yeah.
But I wanted to stop you because I know that the San Andreas fault is actually a misnomer. Do you want to talk about that?
So misnomer in the sense of the San Andreas fault is technically near the plate boundary of the Pacific and North American plates. Yeah. So that's just what we call the major fault line that goes basically from Cape Mendocino up near Northern California and kind of terminates close to the border with Mexico. Maybe it goes a little bit beyond that, but yeah, that's what we refer to as the San Andreas fault usually.
And do you get to talk to the kids about plate tectonics or?
Yes, actually. So during that demonstration with the foam board and the crankshaft, which by the way, shout out to our building manager, Eric, who makes a lot of these demos, and we wouldn't be able to run EYU without him.
Big fan of Eric.
Yeah. So basically, what I'll do is I'll demonstrate the fact that you basically have two foam blocks which represent two tectonic plates, the Pacific and North American plate, and you start out by having them sort of stuck together. That demonstrates that there's what we call locking in earthquakes. So the ground is building up pressure as you try to crank the plates moving past each other, because that's what plates want to do. They want to move past each other. In the case of San Andreas, they move side to side, not towards each other. And basically they build up pressure, and over time eventually that pressure will be released in the form of earthquakes.
So from my understanding, this is because the edges of the plates are not flat, they're super bumpy, and so the bumps get caught on each other.
That's right.
Okay.
Yeah.
And so when like there's a really big bump passing over another one, we get an earthquake?
So when there's a really big bump trying to pass over another
Okay.
one, they get stuck because of friction. It's not like smooth. It's not
Yeah.
like smooth sailing, and so it'll build up pressure, and eventually that ground has a finite amount of elastic energy it can hold,
Okay.
and eventually that elastic energy will be released in the form of seismic waves. Yeah.
Cool.
Yeah.
Seismic waves. Very cool stuff.
Yes.
There's 3 kinds of seismic waves. Would you like to tell the audience?
Yes, there are. Right. So there are 3 kinds. The first kind, it's actually really easy to remember them. So they are P, S, and surface wave. P is for primary, and they're called primary because they're the fastest. They're the waves that you will feel first. And then S for secondary, they're the waves you'll feel second. And then finally, you have surface waves. And the reason they're called surface waves is because they attenuate really quickly in the ground. They don't tend to go beyond the upper less than 100 meters of the crust, whereas the other 2 waves, P and S waves, they actually travel all the way into the earth and will circumnavigate the globe when
Oh,
an
really?
earthquake happens. Yeah.
Oh, that's really funny.
Yeah.
Okay, so that's kind of proof that the earth is round because they'll meet themselves back again.
Yeah, so they sort of will they'll pass through all the different layers, and that's actually how we know that the outer core of the earth is liquid, because a seismologist earlier in the 20th century basically observed that S waves did not pass through the outer core, and S waves don't pass through liquids. And so because they are transverse waves. Yeah, exactly.
Cool. On the topic of liquids, you mentioned a word that sounds like liquid, but I don't think it's directly related. Liquefaction at the booth?
Oh, yeah, that's a separate thing. So
Okay.
that's more, now we're like not deep into it. Now we're actually looking at how, things impact people every day. So liquefaction is when if you have soil that's heavily saturated with water, and the ground shakes, the soil will actually start to behave like a liquid, meaning things that are less dense than water will, or the fluid will float up to the top, and things that are more dense will sink. So cars and stuff will sink into the ground, whereas maybe gas-filled pipes will rise to the top.
Okay.
And they'll maybe burst even.
Okay.
Yeah.
So what are we hoping to learn from this demonstration?
What we can learn from this is that you try not to build your house on soil that is prone to liquefaction, because you don't want your house to sink either, right?
Okay, because your house is less dense than rocks?
So your house is going to be more dense than the fluid, right? And so, because if the soil starts to behave like a fluid, right, anything that is denser, is going to sink into the ground. Yeah, exactly.
Okay.
This actually happened in New Zealand when there was a huge earthquake. You saw cars sinking.
Oh, no.
And then once the shaking stops, the soil goes back to being solid. So your car is basically stuck and buried underground.
Shoot.
Yeah, exactly.
Okay, and unlike actual water, you can't swim through the fake
No,
liquid.
exactly. It's like a slurry of water and soil together, basically.
I'm sorry, I can't stop laughing. This is not a funny
No.
topic. It's so sad.
It's very it's almost like nervous laughter, right? You're like, oh, that's crazy that the earth can do that, but it can, and people's lives are impacted by it.
It's just okay, guess we have to swim in the soil now. It's literally don't touch the lava. But it's cold lava.
Yeah.
Anyway, so you've got the fault demonstrator and the liquefaction at the booth.
Yeah.
Anything else going on at the booth?
Yes, there is. The third thing is demonstrating how shaking impacts buildings of different heights.
Oh.
So this is more like...
I've seen it. Yes.
This is more like a resonant frequency demonstration. So basically, buildings of different heights have different resonant frequencies. And resonant frequency, for those who don't know, is the frequency at which the amplitude of shaking is maximal.
Yes.
Right? And so if an earthquake wave of a certain frequency passes over the building, if it matches the resonant frequency, then the building's going to shake a lot.
Yeah.
Right? Yeah. So what we do is we change the frequency of rotation of the shaking, and that will show you that the shorter building has a different resonant frequency than the taller building.
Okay.
And so, what you can do is you can basically add weights on top of the taller building, or whatever building you're working with, to sort of dampen the effects of the shaking, and the resonant frequency will change if you add more weights to certain floors. Yeah.
And there's a lot of real life examples of this.
Yeah.
Do you know any?
So I know they do that with some buildings in downtown LA, like the taller structures there. In Japan, actually, they have a more from what I know, a more sophisticated approach. They have like these sort of like dampers and in the foundations, and like they have shock absorbers as well. And something else they'll do in Japan is like the buildings will sway in the motion of the earthquake to avoid like breakage, basically.
Like a shock absorber.
Yeah.
The example I was thinking of is the Taipei 101. I don't know if you're familiar.
Yeah, they show that in I believe they show that in the earthquakes class that we teach.
Oh, we have earthquakes class.
Yeah,
so the top of Taipei 101 has this big ball in it that it's this huge weight that counteracts any seismic waves. I've never been to Taiwan. I would love to go. I'm Taiwanese, but I'm allergic to peanuts, so I can't go. Were there any really standout moments of talking to the kids at the booth where you could tell they learned something or they were super excited about something? Yeah,
there was a student last year who really liked the liquefaction one. I think the main thing that I think the liquefaction one is the most interactive one to students, because I'll ask like, hey, you want to push the shaking button? Like they'll be able to like So
do you want to control seismology?
Exactly. That's basically like people get excited when they get to press a button, you know. So that one they liked because there's like toy cars and stuff in there, so just to demonstrate. And so that one I think is more like realistic because they get to be like there was one student who got really excited with the car and be like, look, it's sinking and stuff. So I think that's a really good one, because the other ones like you're sort of showing a demo, like it's not really, the foam is not actually showing the ground like breaking, you know what I mean?
We want destruction. What I've learned from hearing different booth leaders and volunteers is that kids love destroying the booth. And so this one they basically get to destroy the booth.
Exactly.
That's really cool though. This booth has a lot of demonstrations in it and they all sound really fun and super interactive. Is this your brainchild or your advisor's brainchild?
This is, I think, this is a combination of my advisor and Eric's ingenuity, because Eric definitely built all the demos, and my advisor is really big on having his grad students do outreach, because he also talks to the press sometimes when a big earthquake happens.
Your professor is Ling Sun?
Yes, Professor Ling Sun Mang. Yeah, he loves doing outreach as well.
Awesome. We are very grateful to him and to Eric Wessenauer for their hard work on the Make Your Own Earthquake booth, which I'm assuming will appear again this year?
Of course, yes.
Are you going to be the booth leader again?
Yes. Yeah, it's probably my final year of grad school, so I would love to.
No! Well, we are so happy that you're graduating, but also sad that Make Your Own Earthquake is going to have to look for a new booth leader.
I'm sure many people who are passionate about earthquakes do just as good a job. Yeah.
So how has grad school been for you? How did you get here? What is it like? What do you like about it?
Yeah, so I came to grad school in 2020, fall of 2020, middle of the pandemic.
Oh, no.
Yeah, I moved from the Bay Area where I was at for undergrad. And I got into Professor Meng's group just before, like a few weeks before they announced all the shutdowns. And I remember actually the visit day for my cohort was like 1 week before they shut everything down.
Okay, we shut everything down again for Delta variant?
This is the first shutdown, like March 2020.
Oh,
yeah.
Oh, because visit day is in spring.
Yes, exactly. Yeah.
Oh, wait, that's crazy. So you didn't even realize you were applying to Zoom school?
No, I did not. I was like, I'm applying to grad school, and then like, oh, surprise, everything shut down, and like you can't travel.
Oh man.
Yeah.
That's kind of sad. Okay, so you didn't get to come visit UCLA in person before you.
So actually, I did. So I had the visit day, and then they shut down. Like a week later, they shut it down. Yeah.
Okay.
Yeah.
So you moved here in the fall in Ling Sun's group.
Yes.
What were you super excited about when you were moving to grad school?
Yeah, so I was mainly excited to experience a new city. I had been in the Bay for a few years now, but also I really like the department, like our department here at UCLA is like sort of liaising with planetary science and like earthquakes. Like I really like Professor Meng's tsunami warning developments that his group works on, and I also wanted to see this as an opportunity to maybe branch into the planetary science, maybe look at the quakes on other planets even. So I thought it would be a great opportunity to work in this department. That's why I chose to come.
So you actually kind of have like a very different science background to most of our other guests in that your science, and not to be punny, is really well grounded. Like actually has to do with like things people deal with, where most of us talk about planets that we'll never ever go to. So what is your research topic? Like how did you get drawn into this department?
Yeah. Initially, the main thing that I liked was improving our tsunami warning systems.
Okay.
So our research, the first research topic I was really interested in is using my advisor's group's tsunami modeling technique and demonstrating its use value for tsunami warnings. So that was my initial like hook. I spent a lot of the first 2 years, of course, like training and reading reading some papers and familiarizing myself with, just the whole research process, helping more senior grad students with their work before I started to develop my own.
So you actually wanted to help people.
Oh,
I think you're like the only guest we've ever had who like started grad school to help people.
I think all science helps humanity in some way. You know, just like, of course, there's some historical examples where it was bad, but I think science tends humanity towards better things.
Most of us are trying to help, but I don't know. I was kind of like, I don't want anything that's that big of a responsibility to actually be my problem. But helping people with earthquakes and tsunami warning is actually like a really big responsibility that people need to be doing. What are some things that you've learned along the way, or some contributions that you've made to the warning systems?
So, specifically the warning system, the type of modeling we're doing it's called like so in our group we learn about different like what we call inversion techniques. So basically you have like seismic data or tsunami data, and you're trying to go from the data to like model the source of the tsunami. And usually the current tsunami warning systems, they're fast, but maybe they're not necessarily accurate. Okay. So that can result in some false alarms for some places, and then there's more accurate methods, but then they take too long. So our method is sort of the middle of those two, where you're trying to make it more accurate, but also fast at the same time. So the idea is, in a typical tsunami scenario, like tsunami occurs, and the typical fast, like lower accuracy method is applied, that is then updated consistently with our more moderately quick, more accurate method. And so that's the selling point of that.
And what region does your warning system talk to?
So once we have it all like demonstrated and established, we would then want to reach out to like NOAA, specifically for like Cascadia, because up there they're overdue for a major.
What is Cascadia?
Oh, sorry. Cascadia is up north near Oregon and Washington. Okay. So it's called the Cascadia subduction zone. Yeah. Referring to like the Cascades.
No, that's my fault. I don't know U.S. geography.
No. It's all good. It's all good. And then Japan is the one. Is another one that we use Japan as a great test case, because they have a really dense network of tsunami monitoring instruments, and so it's a great opportunity to show how well the method can work in an ideal case, in an ideal system. Cascadia does not have, unfortunately, as many monitoring instruments as Japan, so that's another thing. We can use it as like a selling point, like, hey, get us more instruments up there. We need to prepare for like the tsunami is gonna come eventually. We just need to be prepared.
It is going to come eventually. Cue the nervous laughter again. You don't have to answer this one if you don't want to, but I am very curious, like what kind of careers are open to you after doing this kind of work for grad school?
Yeah, so I not only have done tsunami work, I've also done like trying to understand the physical mechanisms that drive like earthquake aftershocks. Sometimes earthquakes can be driven like by tectonic stress, like we talked about with tectonic plates, but they can also be driven by like fluid movement underground and volcanic systems and all that stuff. And so working on that has also given me some knowledge about like earthquake source modeling, but an aftershock, understanding aftershock models and stuff. And so I would love to branch out and, for the next stage of my career, work on something that's more planetary science focused. And so specifically on Mars, we had actually installed a seismic instrument with the InSight mission.
You and Linkson did?
No, not we. We meaning like people, humans. Humanity. Yeah,
okay.
Sorry. No. The InSight group at JPL, the Jet Propulsion Lab.
I have their sticker.
Yeah, they actually installed a seismometer on the surface, and the data is open access now, and so you can do a bunch of cool stuff with that. They detected marsquakes, and so we can try to use those marsquakes to understand more about the crust of that planet. So I'd like to branch into that more in the next stage.
Dang. Yeah. That's cool.
Yeah.
So you're actually almost like no longer early career researcher very, very soon. How has your academic journey been thus far? Like, were there any huge challenges or hurdles that you had to overcome?
Yeah, I will say definitely lack of research funds was definitely a challenge we needed to overcome. Like, it's, the earthquake field is very competitive for getting like grants and stuff because
Why?
because it's a very it's an issue that impacts a lot of people, right? And so a lot of people when they're applying for grants, they struggle, like at least in our department, with like trying to sell it, like how does this benefit humanity and all that stuff. Earthquake people don't really struggle with that. So they get like you sort of have to set yourself apart from all the other earthquake people who are trying to help.
So you have the opposite problem.
So it's a bit challenging to get funds in that regard. We try. I mean, we submit as many grants as we can, and so because of that, I need to teach more, like, because in our department, if you don't have research funds, you TA, and that's fine. I do like teaching, but it does of course take you away from your research, and so that can lead to maybe being a bit overworked and at times. But I try to keep myself entertained with seeing friends, like doing sports,
like kickball.
Kickball, yeah, our department kickball team, and then soccer also is a big one I like to play, and hiking, of course.
DJ Seis and I were on the department kickball team where we were completely defeated. We won 0 out of 4 games and were knocked out of the intramural league.
Yes, though I think I got a hang of the rules eventually.
I forgot about the rules situation. I didn't grow up playing kickball. I don't know. Okay, so I grew up in Los Angeles. I've never played kickball before. Did you know about kickball before you came here?
I knew about baseball. I knew about softball.
Okay.
I figured kickball was just kicking instead of batting. So like that was my exposure to it.
And you mentioned that you didn't grow up here.
No, I grew up actually abroad. Yeah.
Do you want to talk about that?
Sure, yeah. I grew up in Saudi Arabia and Kuwait. My family's all originally from Lebanon. So, was born in near Northridge and raised there. Raised in the Middle East,
Wait, Northridge?
California.
Okay.
Yeah.
So you were born and raised in Northridge, and then you moved over, and then you came back for college?
Yeah, sorry. Maybe I misspoke, but
you got this. Take your time.
Born in Northridge, raised in Saudi Arabia and Kuwait, and then came back for college. Yeah.
Was there like a culture shock for you?
Or yes. 100%. Yeah. I mean, I did go to a westernized school in Kuwait and Saudi Arabia. They were like British schools and stuff. So I had an exposure to sort of like Western culture, of course. And like a lot of those places are very westernized in a lot of ways anyway. And so I thought I wouldn't be culture shocked, but I went to like Berkeley for undergrad, so I feel like no matter where you're coming from, even if you're coming from America, like a random city in America, you're going to Berkeley, you're gonna get some sort of culture shock.
I was really confused by Berkeley. I spent a summer there, and I grew up in Los Angeles, and I was still like really confused by Berkeley. So I think that's everybody. But this kickball thing, I also didn't really know about kickball.
Yeah.
You wear a lot of hats. So on top of being an earthquake and tsunami researcher, you are also the main talking point for the union for grad students.
Yes.
Thank you for doing that. Thank you for helping me file my grievance when I was not paid that one time.
Of course, yeah.
Tell us a little bit about what it's like to be a union steward for our department.
Yeah, so it's actually not just me, it's also Emerson and Whitaker.
Yes.
They're also the other union steward in our department. So what we try to do is basically liaise with our union and try to basically inform our grad students on what's going on, like how is the union representing you, what can you do to help the union, what the union's doing to help you. So I joined this, I forgot, maybe 2 years ago now. I think it was around when the strike was happening, the more recent, like the 2022 strike.
That was in fall of 2022. I remember because I started grad school in fall of 2022.
Oh, wow.
I had like 2 weeks of school and
started
then it was
with a bang.
we're going on strike.
Yeah.
It was really fun though. I liked it.
I mean, I always do get like sad when we have to strike, because no one wants to strike. No one wants to like stop doing their research for the sake of like asking for basic, work.
I mean, you're literally saving lives the more you work, so it's not like you wanted to step away from that.
Yeah. So it's like you sort of do it because you need money to like pay for rent. You need money to pay for like, you don't want to just also just survive. You want to be able to save a little bit. It's hard to deal with emergencies in the States sometimes if you don't have money saved.
Emergency fund.
Exactly.
Yeah.
So Emerson and I really are passionate about making sure our department's informed and they basically feel that the union is representing them. Yeah.
Thank you for name dropping Emerson. The reason I didn't is because I constantly name drop them on every single episode. And I think our listeners are she's just obsessed with Emerson, but I kind of am.
You guys are best friends.
We are best friends and lab mates, and we do everything together. But thank you for being so helpful to our department, and thank you for all of your service. There is a current ongoing issue that you wanted to talk about?
Yeah, so actually our unions currently, we actually started bargaining with the UC because our contract is going to be up in December. Mm-hmm. And one of the things we are trying to demand from the UC is protections for international student workers. Yeah. So given everything that's happening with visa issues and, detainments and deportations, we want to make sure international students feel supported. And so some of the demands we have are setting up a legal defense fund for anyone impacted by immigration changes, providing financial support to help people stay employed. Yeah, and taking all measures to restore immigration status for people who've been targeted, things like that. Yeah. And actually, our union was able to win one of these things recently, which is setting up the legal defense fund.
Oh my God.
Yes, so
that is so stressful.
Yeah, exactly. So, but they were only able to do that because we're showing the UC that their grad student and their employees care about this thing.
Yeah.
And so there's a petition going around that people can sign, grad students can sign, or even postdocs and other academic researchers. So if you really want to support your fellow international workers, if you see any emails asking you to sign that, please do that.
This episode comes out in August.
Oh, that's also fine. That's also fine. Yeah.
I'm sure we'll be out there fighting for something else by the time August rolls around.
Of course.
Things just keep happening to us.
Yeah, it's not like, the Trump administration is going to stop what they're doing in August.
Nope, 3.5 more years. Anyway, thank you for sharing that very important message. I'm sure everybody who listens to it is going to sign all the petitions that come their way. I don't want to say this too loudly because it's kind of embarrassing, but I just sign everything Emerson puts on my desk. So I've signed a lot of these things recently.
You trust them.
Yeah, absolutely. Yeah. You have come a very long way from growing up in Northridge, and now you are almost going to be a doctor. But at some point, you were some small child who I'm guessing was fascinated by earthquakes.
Yeah. That's true.
And so if you were a child, let's say, at the Make Your Own Earthquake booth, pushing the little liquefaction button, what would you have wanted to hear from the adults at EYU?
I would have wanted to hear, don't sell yourself short. Mm-hmm. You are capable of being a great scientist, and you are more than you give yourself credit. You're your own biggest critic. People's biggest critics are themselves. And so basically, with hard work, anyone can, I think, become a decent scientist.
Decent.
So, yeah.
That's my new goal. Decent scientist. Can I at least publish something with no typos?
Yeah.
My first paper has a typo in the first line of the abstract.
Oh, God.
So it happens.
Yeah.
I think every single guest has come on our show and shared a little bit about imposter syndrome.
Yeah.
What are your tips and tricks for overcoming imposter syndrome, if you have any?
So it's a work in progress for sure, but I would definitely say my favorite thing is actually talking to people at outreach events.
Yeah.
Or someone who's not even in your field, or even other scientists who aren't even in your field. Because when I talk to scientists who aren't in my field and I hear about their research, I feel a little bit of course I feel a bit dumb, and that's because that's not my field. Mm-hmm. But then when I hear them talking about it, I'm like, oh, that person is really smart. They're really good at what they're doing and all that stuff. So that's probably happening when I'm talking about my thing to them. Right?
I can confirm it is happening when you're talking to other people.
Yeah. So that kind of reminding myself of that is just puts things in perspective for me. Yeah.
I like this answer because it encourages people to go to outreach events and make community with their fellow scientists.
Exactly.
That's great.
And it also trains your science communication. Also, it makes
absolutely.
I think it makes you a better scientist. If you're able to explain your science in simple terms, I think that makes you smarter. Yeah.
Thank you for rehashing all of the main points of the EYU radio show. Where can people keep up with your science?
So they can keep up by looking, I guess, at specifically my science on my Google Scholar page, but also Professor Meng has his personal website where any publications that his group outputs are on there. And so if I publish something with him, that's going to be on there, and you can follow the links to that. You can also, of course, find me at EYU. There are sometimes, if like random outreach events pop up in our department, I also go to those. So yeah, keep a lookout for that.
And in the future, can people find your tsunami warning system?
Well, demonstrating something scientifically is one thing, but then lobbying for it to be implemented in a government thing is a whole other beast. That maybe someone who's more senior than me and has more sway can try to get, I guess, NOAA to do.
Yeah, so if NOAA is still alive in a few years, hopefully you will see DJ Seis' tsunami warning on there. Oh man, the nervous laughter. Yeah. We love you, NOAA. Hopefully you stay alive.
Yes.
Well, thank you so much for joining us. Are there any final words or thoughts you want to share with the audience?
No, just show up to EYU, learn about science, learn about the universe around you.
Yeah, absolutely. Yeah. This is DJ Stellar Cloud and
DJ Seis.
Signing off. With that, never stop exploring.